Hello students, welcome to this session which is going to be on rational and irrational numbers. Now you must be a little familiar with this topic. I'm sure you guys have studied it under the topic of real numbers, but nothing to worry in case we haven't. Okay, there is going to be a quick recap on what rational, irrational numbers are, the divisions, and they will be an amazing game that we would be playing. And then I would be telling you quite a bit about how math is probably quite a lot based on the pattern recognition. So there are going to be quite a lot of patterns that you would see, and hopefully you shall be able to decode them out as well. Okay. Now, before we begin, all right, just let me know if I'm audible and visible by giving me a thumbs up, and after that we shall be ready to begin with this session here. So Rashmi here says, hi, good evening, Rashmi, let's get agitated again, hi. Himani says hi, Rajesh says hi. Okay, so I am getting thumbs up here, which means yes, I am audible and I am visible. So come on, let's begin the session now. But before we do, in case you haven't done this already, make sure you subscribe to this channel so that you are able to receive all the updates and notifications on time. All right, so come on, let's start off now with a little recap on the classification of what real numbers are. Okay, so real numbers have been broken down into two major categories. One is your rational numbers, okay, and the other, of course, is irrational numbers. And there will be a little game that we will be playing based on that. So that's the reason why I thought you should be familiar with the concepts. Otherwise, the game wouldn't make sense later. Okay, so first let's go ahead and understand what rational numbers are. Now, these are numbers that can be expressed in the form of a fraction. Okay, like let's say a fraction in the form of a by b, where of course we know this. The denominator can't be equal to 0 because division by 0 is not defined in mathematics. Okay, some examples that I could give you of rational numbers are, let's say 2 by 7, minus 5 by 3, or even a number like minus 5, because minus 5 can again be written in the form of a fraction as minus 5 divided by 1. So any number that can be expressed in the form of a fraction is going to be rational. And irrational, well, it's going to be the opposite of that, right? So irrational numbers, they cannot be written in the form of a fraction. All right, so this is the definition of rational and irrational based upon the concept of fractions. Now let's try and check the definitions based on the idea of decimals. Okay, so rational again are going to be two types. First is, of course, they are your terminating decimals. Okay, terminating decimals means what? These are the decimals which terminate, which have an ending. Like let's suppose an example could be 0.75. This is terminating. Or something like 0.1375. This also terminates. It has an end. All right. And the second one is going to be non-terminating. Okay, non-terminating, which of course means they do not terminate. They go on and on and on. But they will be a recurring pattern that you will be able to see. Okay, non-terminating and recurring. I will give you an example for this one as well. Non-terminating recurring is also by definition rational, which means you can convert it in the form of a fraction. Remember that, okay? An example for non-terminating and recurring is going to be what? 0.2353535. Okay, so you see it goes on and on and on, but you see a pattern here, right? So if I were to tell you what the pattern is, well, these are the two digits 3, 5, which are going on and on and on. Okay, so have we understood? Another example, come on, go ahead, you type it out in the comments box. What could be the example for non-terminating and a recurring decimal? Okay, non-terminating and recurring. I can give you one more example. Okay, that could be 0.5783783. So you see it goes on and on and on, and you can see a recurring pattern here. If I were to put bars on top of digits, this is how we do it. Okay, 783, well, that's a pattern which is repeating. So we've understood it, and I am getting plenty of examples. Prashansa, Dayananda, Tatlin Kaur, Gungun, very good. So you've understood it. All right, so rational. Now irrational, if we were to follow the definition of decimals there, this is going to be non-terminating, okay, which means it doesn't terminate. And you would also not see any recurring pattern in it, okay, non-terminating and non-recurring. So this is going to be irrational. Well, the most beautiful irrational number out there is going to be pi. Pi is irrational. Now, some of you may be thinking, hey, sometimes I take pi as 22 by 7. You do that, right? But then if I take pi as 22 by 7, I am expressing pi in the form of a fraction. So wouldn't that make pi rational? Well, you would be right in that argument, but then pi is not 22 by 7. It's just an approximation. Remember that. The actual definition of pi is the ratio of the circumference of the circle to the diameter of the circle. That is how pi is properly defined. 22 by 7 is simply an approximation. Okay. Some other examples are root 2, root 3, root 5. So all of these are going to be non-terminating and non-recurring. I'm sure you guys are familiar. E is irrational. Of course, E here is also going to be irrational. Well done. Now, irrational part was fairly simple. Now, what happens is sometimes they give you a fraction, okay? And they ask you, is this going to be terminating or is it going to be non-terminating and recurring without actually performing the division? So there is a trick for you to be able to do that, and that is if the denominator, okay, let's say the numerator is some p. If the denominator here is in the form of 2 to the power m multiplied with 5 to the power n, just focus on the denominator, then the decimal is going to be terminating, okay, where m and n are integers, okay. But if the denominator is not in the form of 2 power m multiplied with 5 power n, then it's going to be non-terminating and recurring. An example that I could give you is, let's say, 3 by 10. Okay, just focus on the denominator here. 10 can be written like what? 2 multiplied with 5. So 2 power 1 multiplied with 5 power 1. Now this is in the form of 2 power m multiplied with 5 power n. So this is going to be terminating, and the answer is going to be 0.3. But let's say you have 3 divided by 11. Now the denominator 11 is not in the form of 2 power m multiplied with 5 power n. So for that reason, this is going to be non-terminating and recurring. So you've understood the quick recap as to what classification is. Now let me just go ahead and read out a few of your comments there. E is irrational, right? Yes. Deepak, E is irrational. And you probably have, using the combination of E, pi, and an irrational and an imaginary number that you shall be studying in 11th or 12th grade later on, you have this equation. E to the power I pi plus 1 is equal to 0. Now this is known as probably the most beautiful equation in mathematics. So E is irrational, pi is irrational, I is imaginary, and to the power, the result is equal to -1, right? So yes, E is going to be irrational. And yes, pi is 3.14 is simply an approximation. It is not the exact value. It is the approximate value of pi. Pi is going to be non-terminating, which means it's not going to end the decimal part, and you would also not see any recurring patterns to it. Okay, Rashmi says, what means sir? Okay, Rashmi, a question needs to be a little bit more precise. I don't understand what you're trying to ask here. I'm simply telling you that pi is going to be non-terminating, which means the decimal part is going to go on and on and on. And like these examples that we've taken, there is not going to be any recurring pattern, like let's say any random numbers. 3.142857312, whatever. It goes on and on and on. That's all. Okay, cool. All right, clear. Yes, E is called as Euler's identity. Okay, you are going to encounter that later on in higher grades. For now, yes, it is enough for you to understand that E is also going to be irrational. Okay, all clear? Come on. Now that you have an idea as to what rational is, what irrational is, and how do you decide if a fraction is terminating or non-terminating and recurring, it's time that you understand some patterns. Okay, and I'm going to throw in a beautiful pattern out for you. Okay, now have a look at this, and please pay some concentration to this. This is definitely going to blow your mind, I promise you that. So 1 when you divide it by 9801. Now 9801 happens to be the square of 99. I'm sure you are familiar with what 99 square is. 99 square is simply going to be what? 99 multiplied with 99. And when you do that, you get 9801. Now when you put this stuff in a calculator, okay, this is what you're going to get. 0.000102 03 04 all the way up till 9, 9. Okay, and the pattern is going to again repeat. Again, it's going to be 0, 0, 0, 1, 0, 2, 0, 3, all the way till 9, 9. Again, the pattern is going to repeat. Isn't that beautiful? I mean, you're getting the set of all the whole numbers here from 0 to 99 when you divide 1 with 99 square. Now, the pattern doesn't stop here. It keeps extending. Okay, like let's suppose I divide 1 by 999 squared. This time instead of 99 squared. This is going to again follow that. Okay, again, if you notice here, this is what, as I said, 99 square, right? 99, how many digits? 2 digits. So that's the reason why your combination is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 2 digits at a time, right? Now, can you guess what this is going to be? This is again going to be a beautiful pattern. Okay, 0.000, 001, 002, 003, all the way up till 999. Okay, and again the pattern is going to repeat. And that's the reason why I told you in the beginning that patterns is what mathematics is all about. Okay, we observe patterns in nature and then we try and decode them, express those patterns in the form of an equation, and we have it. All right, so yes, this is not going to be terminating. This is going to go on and on and on, but this pattern will keep on repeating. And the end here is connected to the denominator. Okay, and this is going to go on. Even if you're dividing it by 1 by 9,999 square, the same pattern is going to repeat. Okay, wasn't this amazing? Yeah. Now, using this, I'm going to throw a question at you. Okay, because I believe all the students, we have it. We are hardwired, this is according to me, we are hardwired to decode these kind of patterns. Because sometimes, look, we make silly patterns of our own as well, right? Like when I used to be a student, I had this pattern in mind. I'm only going to pass in this exam if I'm wearing a black shirt. I mean, that's a silly pattern, but it is a pattern, right? Or let's say if my most difficult subject is falling on Tuesday, no, that's not good news for me. Okay, so those were some patterns. So we see patterns even in places where there are no patterns. So how can we not figure out patterns when we have patterns? Come on, I'm going to throw this question at you. Let's see how many of you are able to answer this. So the question is this. Let's say you have a number n. Okay, the number is 99999. You can write it as many times as you want to, and in order to scare you off, I'm going to give you quite a big number here. So this is the number. What you've got to do here is find the number of nines and the number of zeros in n square. Now this problem is quite crazy because I have given you, first thing, a huge number. Okay, this is the number that I have given you. I don't even know how many times I've written 9 there, but yeah, this is quite a big number. So what you've got to do is first square it, okay, and then tell me how many 9s are there in the answer and how many zeros are there in the answer. Now, when you're trying to even put this number on a calculator, the calculator is going to tell you, I'm sorry, I don't have that much space to display you the digits, so that's not going to work. And that's the reason why we've got to observe a few patterns here. Okay, so when you observe these patterns, like let's say there are only 2 9s, this is going to be 9801. All right, let's suppose you increase this to 3 9s and you take the square of that, this is going to be 998001. Okay, I'm going to throw one more hint and then the pattern is going to become obvious after that. Let's suppose you have 9,999 and you're taking the square of that. This is going to be 9998001. Have you found the pattern yet? Have you found the pattern yet? I'm sure some of you have. If you have, type it in the comments. Yes, you're missing an 8 there, that's all, no problem. But then the pattern is this. Look, how many 9s are here? There are 4 9s, and you're taking the square of that, and the answer has 3 9s and 3 zeros, right? Let's suppose you have 3 9s here. You're taking the square of that, the answer has 2 9s and 2 zeros. The number of 9s and number of zeros are equal. So what do? 1 less than the number. Count how many 9s are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in the number that I've given you, 9 happens 15 times. So when you take the square of that, how many 9s are there going to be? Well, you're going to have 14 9s, then 1 8, 14 zeros, and then 1. Okay, so that's a pattern. Once you understand the flow of patterns here, that same idea could be applied, and then you generalize it and you get a result. Okay, so that's how this is going to work. Okay, so this number n has 15 9s, so this square you can write it without even using the calculator. Just 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So 14 9s followed by 1 8, and then 14 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and then 1. Such a big number. But then yes, once we've decoded the pattern, we have the answer. So this is what I wanted to show you guys today, that math is all about figuring these patterns out, and formulas and equations simply tell you a story. They tell you the generalized form of whatever pattern you observe. Okay, now I believe we are ready to play the game. Make sure you recollect the concepts that we've covered: terminating, non-terminating, rational, irrational, and be ready to participate in this. All right, so we're gonna learn this in quite an interesting way. So the game is gonna come up now. Okay, so all right, so let's start off with this game here, rational and irrational numbers. I'm going to click on play and let's see what happens now. Okay, so this one, what does it look like? Well, this is Math City Airport. Okay, you are the officer, by the way, there. Now your duty is to load the packages. Okay, there was something, I missed it out. Cool. And then each package has a unique number on it. So you've got to figure out if this is belonging to the rational terminal or the irrational terminal. Okay, so if the package has a rational number, quite obvious, you send it to the rational terminal. And if it has an irrational number, you're going to throw it down to the irrational town or irrational terminal. Okay, so terminating, non-terminating. Come on, the first number is 7 by 50. Observe the denominator and tell me if this is going to be terminating or non-terminating. Come on, observe the denominator there. What is the denominator here? 50, right? When you factorize it, 50 can be written like what? 2 times 25. Yes, 2 is nothing but 2 power 1. 25 can be written like 5 square. Now, if you notice, the denominator is in the form of 2 power m multiplied with 5 power n. And when the denominator is in the form of 2 power m multiplied with 5 power n, what do we call it? What is this going to be? Is it going to be terminating or is it going to be non-terminating? Well done, well done. All of you are giving the correct answer. Yes, this is going to be terminating because the denominator is in the form of 2 power m multiplied with 5 power n. Now I'm going to try and click this out here. Terminating. Well, yes, we are correct. Good job. Terminating. This can be written in this form. It's also giving you an explanation here. All right, come on, let's move on now. We've understood that this is terminating. Okay, what do I do to carry this forward? Okay. Cool, so this is going to be a terminating decimal. Awesome. So we've stamped this package as the terminating decimal. Now the next job is to decide, yes, this is the explanation given to you. I'm sure you've understood it by now. Since the denominator is in the form of 2 power m multiplied with 5 power n, this is terminating, right? And now we've got to decide if this is rational or irrational. Come on, this part has to be fairly simple. What do you guys think? This is rational or this is irrational? Well, the answer is in the number itself. It is a fraction, right? Irrational numbers cannot be expressed in the form of a fraction. Well done. Prashansa, rational. Anchal says rational. Rashmi says rational. Aishwarya, rational. Rajesh, rational. All right. All of you wonderful students are giving the correct answer. Yes, this is going to be rational because this is already in the form of a fraction. So I'm sending it out to the rational town. Okay, so I'm sure you guys are familiar with the game now. So this was what it was, terminating, non-terminating, and all of that. Come on, let's move on now. And let's bring on a different number now. Let's see how many of you can answer it this time. Okay, so be careful. I have 1 divided by root 2. Even though it may appear like a fraction to you, but still use a little bit of reasoning and then try and tell me the correct answer. So 1 by root 2. What can you say? This is, if I write root 2, you know how to write root 2, right? Root 2 means 2 to the power 1 by 2. And what did I tell you? If the denominator is in the form of 2 to the power m multiplied with 5 to the power n, but m and n have to be integer values. 1 by 2 is not an integer, right? What are integers? 1, 2, 3, 4, 5, 6 all the way, 0, and then minus 1, minus 2, minus 3. These are, of course, going to be your negative integers. 1 by 2 is not an integer. So what is this going to be? Well done. Well, some of you have already gone to the irrational down there and given me the correct answer, but still, what would be this one here? Is it going to be terminating or is it going to be non-terminating? Well done. What I see here is non-terminating. Awesome. Manoj is asking for which class is this? Don't worry about the class, Manoj. Enjoy the session. It's going to be applicable to 4th, 9 and 10 as well. So this is, of course, we've seen it. This is non-terminating. Why is it not clicking? Okay, we have the correct answer. Well done. So this is a non-terminating decimal. All right, awesome. Now the next part is where we've got to decide if this is rational or irrational. So I'm going on there. Okay, so is it recurring or non-recurring? Again, the next bit, we've understood that this is non-terminating, but is it recurring or is it non-recurring? As you can see, they've given you a hint here. 70710, so you don't see any recurring pattern out there, right? So it is quite a random pattern. So this is going to be non-recurring. Very good. This is non-recurring because you don't see any particular pattern that is repeating out there. So yes, non-recurring for this. And moving on from this, I think we are ready to put the final stamp. The final stamp. Is it going to be, yes, rational or irrational? You've already given me the answer. Non-terminating, non-recurring. Of course, that only means one thing, and that is irrational. Okay, so we have the correct answer this time as well. I'm going to bring in the last number, and after that, probably we call it the end of the game. The last number coming up, because I just wanted to revise these basic fundamentals before we move on with the topic. So here's the last fraction coming your way, and that is 11 divided by 30. Come on. First thing is, tell me if this is terminating or non-terminating. Just look at the denominator. Denominator is 30. Is the denominator in the form of 2 power m multiplied with 5 power n? It's not. I have 3 coming in, okay, breaking the partnership between 2 and 5, there is an extra 3 there. So this is not going to be in the form of 2 to the power m multiplied with 5 to the power n because I have a 3 power 1 there. So for that reason, I'm going to have to say, yes, this is not going to be terminating. So we've got the first part correct. This is non-terminating. Okay, so you've understood the reason as well. I have just looked at the denominator, and since the denominator was not in the form of 2 power m multiplied with 5 power n, I've made my decision that, hey, look, this is not going to be terminating. Now, the next bit. Is there any recurring pattern to it, or this is going to be non-recurring? What do you guys see? 0.366666. So they've given you the hint right there, right? 6 is the digit that is repeating. So what do you guys think? Is it going to be a recurring or a non-recurring? You see a pattern. Well done. Dayananda already has the answer. Sukhjot says recurring. Well done, guys. You are correct. There is a recurring pattern, and that is the digit 6. Well, repeating or recurring. So I'll click this. Very good. So we've marked the two things. So what is this now? This is non-terminating, and this is recurring. So the next bit is going to focus on what? It's going to ask you if this is rational or irrational. I mean, this part should be fairly simple, right? Because it is already a fraction. 11 by 30 is already a fraction. So any number that can be expressed in the form of a fraction, well, yes, this is going to be a rational number. Rashmi has the answer to this. Very good. Dayananda also has the answer. Jivita, I think, must have made a small mistake by saying irrational. Remove the first I and the R. Jivita, you will have the correct answer. This is already a fraction there, right? 11 by 30. So it can't be irrational, right? So I will go with rational here. Awesome, right? So you have understood the fundamentals of how real numbers are broken down into rational and irrational, and how the classification on rational, irrational works as well. I'd suggest you play this game whenever you have time. It's fun, and you know, the concepts become fairly clear. So let's move on now. Okay, so we are back, done with the game. Yes. So Shivan says, which airport gives this service? Even I'm not familiar. Must be an imaginary airport for math enthusiasts, right? Like us. Better way to learn. That's all. Cool. So we've learned these things in quite an interesting way. We've seen how math is pattern recognition, right? Recognizing the patterns. And that's it. You know, we've got you covered. We come up with these sessions so that you learn in an interesting way. You understand the concepts because it's really important to understand the language that we are speaking. And if we are not understanding the concepts and still solving the problems, well, it would be like you're talking, but then you don't understand what you're talking. So math fundamentals has to be absolutely crystal clear. Yes, we've got you covered. And then you will find a link in the description box that is gonna, let you have a free trial class. Make sure you utilize that opportunity so that you get to know how learning happens here at BYJU'S. And of course, the last thing, if you like the content, make sure you like the video and share it among your friends. They may also find it quite helpful. And the last thing, if you haven't subscribed yet, make sure you do. You don't want to be missing out on any fun updates that are coming your way. Awesome, guys. That was it from my side. I hope the patterns that you've seen were fun, right? And the way we've studied the decimal system today, rational, irrational, must make it worthy of remembering and understanding these concepts for you. So I'll be meeting you next time as well. So until that, keep practicing. That's how you get better at math. Trust me, keep practicing as much as you can. And remember to take care of yourself. Thank you for your time. Bye-bye.